In this lesson, I'm going to talk about the transformation of quadratic functions. And this is going to be just a quick overview of stuff that we would have covered in our traditional classroom. So I'm going to skip over some of the things we would have done as a class. We are going to look at this function right here, this g of x equals a, parentheses, x minus h squared and plus k, and to decide how do the a, the h, and the k affect the graph of our quadratic functions. And here's how I'm going to help you out a little bit. The h is our horizontal translation. So this is movement from left to right. And the K is our vertical movement. So this is our movement up and down. Take a moment and pause the video. If you don't have this note card written down, if you are an Algebra 2 student, this would be actually very helpful to you. So let's look at an example here. So describe the transformation of f of x equals x squared, represented by this graph right here, and then graph each function. If we recall, our parent function, or the main function that we are talking about here, had an a, then it was an x minus h squared, and then a plus k. So let's put everything in terms of this. So we've got the a, which would be 1, the x, the minus, the h, and then we have a plus. So instead of a plus, we have a minus. So let's change this to plus and negative. That means a is 1, h is 1, and k is -3. The a, if a is 1, it's actually not affecting your graph at all. Anytime you take something times 1, you're left with the same thing you had. But remember what I said, the h is our horizontal movement. So +1 means we are going right 1. K is -3. That's our vertical movement. That means we are going down 3. And this is telling us the location of our vertex. So our vertex of any parabola of our quadratics is always h comma k. So if you can find this h and k, you can find the vertex. So in this case, our vertex would be 1, -3. H is always the opposite of what it looks like it is up here. Right now it looks like it's a -1, that's why h is a +1. So 1, -3. Here's our vertex of our graph. And then to actually graph it, we'd find some other points that would work for this. And you can do that by typing things into the calculator. You can use Desmos, whatever is going to make the most sense to you to be able to get those points. Even if it is a traditional t-table, that is totally fine. But if we have 1, let's go ahead and do 0 in there as well. So if you plug in 0, we get a -2. And then just for the fun, let's plug in -1, we get a 1. So 0 is -2, -1 is 1. And if you recall, these graphs look like a U, which means it's going to mirror across. And that does make me curious. -2 would actually be a 6. 1, 2, 3, 4, 5, 6. So that'd be right here, and we know that's going to mirror across to this side. This is our transformed function. And it says graph each function, which means we also need to graph the parent function. The parent function is just y equals x squared, meaning the h and k don't move. So our parent function starts at 0, 0, and follows these points, which you could get using Desmos or making a t-table like what we just did. And then we could see once again that our graph moved right 1 and down 3. So here's our transformation, and here's our graph. All right, here's another note card. So reflections. This is if we were to throw some negatives in there, what it does. Over the x-axis is going to be our most noticeable, which means I'm going to take everything except for what's inside parentheses or absolute values. I'm going to take it times a -1. Over the y-axis means I'm just going to take the x, only the x times a negative, and then I can simplify from there. And likewise, stretches and shrinks kind of follow that same suit, except for I have these reversed of the other one. Horizontal, you're going to multiply the reciprocal only to the x. So this is going to go directly on the x, and I would recommend using parentheses for that. And the reciprocal means if it's a horizontal stretch of 2, you're going to multiply by half. Vertical means I'm going to multiply everything in there times my stretch. except for what's inside the parentheses or absolute value. So let's describe the transformations represented by G and then graph each function. The order of which I would describe. So let's see, description, order. The first one I'd look for is reflections. That means, do you see any negatives? The second thing I'd look for are stretch and shrinks. So is there any multiplication? Well, let's see if I have room to write this. Oops, didn't write the C. And then the last thing I'd look for is translations. That means ups and downs, lefts and right. Translations. And you note this by addition or subtraction. So this is the description order. So when we're describing a transformation, this is what we look for. Let's look at this problem 5 here. Do I see any negatives? So and this subtraction is not a negative. So do I see any negatives? No. That means I don't have any reflections. All right, stretch and shrinks. Do I see any multiplication? Yes, I see a multiplication of 1/3. That means I have a stretch or a shrink. So now I have to determine, is it a stretch or is it a shrink? If my multiplication, let's see here, let's do this. If the multiplication is greater than 1, it's a stretch. Otherwise, it's a shrink. So is my multiplication greater than 1? No, it's smaller than 1. That means I have a vertical shrink. Here, I'm just going to type it. Ooh, that's really big. All right, so I have a vertical shrink of 1/3 is one transformation. All right, now that's all of our multiplication and division. So the next thing I'm looking for is there any addition or subtraction? Well, there's a subtraction to the very end. When I subtract things to the very end, so if I go back and look at this, at the very end, that's a vertical. Since it's at the very end, it's a vertical. Let's get back here. Here we go. And it's a subtraction. So that means this is going down 6. So we'll come back and actually graph this in a second. Let's go over here and look at this one. Do I have any reflections? Well, is there a negative? Yes. It is inside the parentheses and it is on the X. That means I do have a reflection. So is it out front or on the X? Well, it's on the X, which means I have a reflection over the Y-axis. If it was out front, it would be outside this parentheses. So I have a reflection in the Y-axis. All right. Now, a stretch or shrink. Do I have any multiplication? Yes, I have a 4 right here on the X. So it's not out front of everything outside of the parentheses. It's inside the parentheses. That means it's a horizontal stretch or shrink. And it is the reciprocal is what had been multiplied. Well, what's the reciprocal of 4? The reciprocal will be 1/4. Well, greater than 1 is a stretch. So 1/4 is a shrink. So on this one, we have a horizontal shrink of 1/4. The negative is taken care of with the reflection, so I kind of ignore that negative. Do I have any addition or subtraction? No, so I don't have any translations. So here's your descriptions. The next thing we're going to do is actually graph these. All right, and you can do this by using your graphing calculators or Desmos, whatever makes the most sense once again. So let's make a t-table. At 0, we're at -6. 4, 5, 6. 1 is kind of an ugly number. 3 is -3. 4, 5, 6 is at 6. And then we can mirror these across, or we can just type in like -3, you'll get -3, -6, you'll get 6 again. And here's our parabola. Let's do our best to graph this. Woohoo! Okay. I apologize, my graphs are a little bit weird on a computer. All right, here's this graph. All right, now let's try this one. Once again, type it in exactly as it is, -4x inside parentheses with your square on the outside. And then we can start typing in numbers. We see that 0 is 0. But then even if we go to 1, we get to 16, which is way big. So let's talk about how this is going to work. Let's go by 4s on our y-axis. That means that my first line here is 4, then 8, 12, 16, 20, 24, 28. And then I can still go by 1s on this. So this would be like 1, 2, 3, 4, 5, 6, 7. And it'd be negatives on the others. But I'm only going to label that much for now just to make it a little bit easier. All right. So 1, we got to 16. 2 is clear to 64, so it's not on there. That means -1 is 16, and our graph is super narrow. And that's our graph. All right, the next thing we have to do is we have to write a rule. So instead of describing the transformation, we actually have to do the transformation. Our original function that we're going to transform is x squared minus 5x. And now let's go through and actually write out all the things that we're going to have to do. So the first thing we have to do, translation 3 units right and 2 units up. So let's do 3 units right. Then the next thing we're going to do, we're going to color coordinate this, is 2 units up. And then we have a reflection in the y-axis. A reflection in y-axis. And this is my recommendation, is to actually do it this way. Have those note cards out with your transformation rules. So 3 units to the right. If we bounce back here to that, so right is horizontal, so we're going to add the opposite only to the x. So using parentheses for every x, we're going to add the opposite to it. So 3 units right, we would think would be a +3. Well, it's adding the opposite, so it's adding a -3. So using parentheses, we're going to do a -3 on this x and a -3 on this x. Everything else just gets rewritten around it. So then we have this. Then we could simplify this part. We're not going to actually do anything with this. We're going to leave it alone. That square does not distribute. You would have to actually do a bunch of multiplication, and we're not going to do that. 5x plus 15. All right. The next thing is 2 units up. So that is a vertical translation. And that says to add the number to the end of the equation. So here's my whole equation that I have. And I'm going to add that number, so +2. And then I'm going to simplify all this. So x minus 3 squared minus 5x plus 17. All right, and then we have a reflection in the y-axis. So coming back here, not that one, reflection over the y-axis, you're going to multiply just the x by a -1. And it says use parentheses. So just the x, so we have 2 x's here. What that means we'll do is we're going to use a -1 times this x and a -1 times this x using parentheses. And then everything else gets rewritten around it again. And then we'll simplify. So we can simplify in this parenthesis here, which gives us a -x, and still -3 squared, minus 5, and that will be a negative x. We'll come back and simplify that again. And then let's simplify. Okay, I can't do anything here. This square does not distribute. I cannot stress that enough. So negative x minus 3 squared, and then negative 5 times a negative x would be a positive 5x plus 17. And write a rule for g. So this is our g of x. So we just wrote that rule. All right, now if we were in class, I would have you try it. So instead, what I'm going to have you do is pause the video right here, try to do this transformation, and then check your answer. So if you haven't paused it yet, I'm about to reveal the answer. So here's the answer you should have gotten if you did it right. Good luck, and I'm sure you guys will do awesome.